and it's a distinct pleasure to introduce Ron Hock of Hock Tools. And I'm sure all of you know Hock Tools and may even know Ron. You may know him also through his book, which I just finished reading. And Ron, I mentioned this to you, and there it is. There it is. And I will include a link in chat right now to Ron's website where you can take a look at that.
Thank you. That's
yeah, and it's really a great read. And Ron, it's a fun read too. I think I have a sense of your sense of humor now. It really came through in the book. So it's really a terrific book. And that may be another way you know Ron. So brief introduction, and this may not be necessary, but I'll because you probably already know Ron. But back about 40 years ago, I think it was 1981, right, Ron? You decided to move on up from SoCal, from the Los Angeles area?
Yep.
To Fort Bragg, and you had an idea of starting a business making kitchen knives. And I don't know, you seem to have really good timing, because the same year, go ahead.
I got lucky. It wasn't timing, it was just serendipity, just dumb luck. I fell into it and I couldn't be more grateful.
What Seneca.
Keep going, don't stop, it's okay.
No, but Seneca, the Greek philosopher, says success is the combination of preparation, or opportunity is the combination of preparation and luck. So I won't give you all 90%,
and 90% of success is showing up, right?
There you go. Who's that?
Woody Allen.
That's right. That's right. So what we're talking about, if you can't already guess, is the same year Ron moves to Fort Bragg. Guess who else does? Krenov. He was invited in 1981 to start the College of the Redwoods Fine Woodworking program. And they didn't know each other. But interesting story that the staff of the Krenov School and the students, I guess, found you, Ron, and started asking you, can you please make us some blade irons? And to all of our benefit, they convinced you to do so.
It actually took them a little effort, because I had my head in this knife thing, and they talked me into it, and one thing led to another, and here we are. All these
the
years.
rest is history. Now, in the early days, you were making all your irons with hand grinding and pre-digital machinery. Is that right?
I still don't have any digital machinery here.
Tell us a little bit about the French factory that because demand is.
France that's doing most of our production for all the shiny blades, all the routine, the replacement blades, they're all being done there.
Give us a sense of Hock Tools. How big of an organization?
Oh, well, there's me, there's Larry at 12 hours a week. Mark, who is the shipping guy, is doing more than that. He does less than 30 hours a week. Yeah. And my wife, Linda, does all the email newsletters. I hope you're all on the list. That she does all the marketing type stuff. That's the organization.
Wow.
Yeah, wow. It's megalithic. It's huge. Yeah.
But
we have about 1,200 feet in a shop down on Main Street.
Incredible. Well, you've been super productive, and you're so important to all of us. So
we've been sticking with it. We've been showing up for 38 years. Yeah.
Yeah. Your father was in the sheet metal business?
Sheet metal, bakery and restaurant equipment, sheet metal and extrusions, aluminum, welding, sheet metal, bending and riveting and stuff to make racks and cabinets for bakeries and restaurants.
And you worked with him?
I was real comfortable, and I worked for him a lot. Throughout college and through graduate school, I always had a job. And then I worked full time for him for a couple of years before I don't know if anyone's ever worked for their father before.
I have.
How'd it go?
It was mixed.
Touch and go.
Yeah.
And our relationship started to deteriorate, so I decided it was time to quit. I gave him 1 year's notice. I said, Dad, if you want to sell the business, I'll stick around for a year, and then I'm out of here. So it saved our relationship. Nice. He moved out to the desert down in Southern California. We moved up here. We were good friends right up until he died. So that worked, but I discovered that I couldn't work with my father. he would only allow me to work for him, not with him. Does that make
I
sense?
see. Yeah. So it wasn't a partnership. You didn't.
So it's a long story, but whatever. Yeah. So I'm comfortable with the metal thing. I moved up here. My wife tells a story that at some point before we moved up here, I woke up in bed one night and said, "I'm going to make knives." I don't remember that event, but she tells that story all the time. So I started making knives. I went to the local lumber mill. I had a 1969 Volkswagen bus. That was our primary vehicle. And they allowed, I said, can I get some saw blade scrap? And they said, well, we've got a scrap guy. He's not going to like it, but he said, just do it once. You have one, it's a one-time offer. So I still have a whole bunch of it leaning up outside of the shop, but it's bandsaw blades that are this wide, you know, with the big teeth on both sides. They're almost 100 thousandths thick. They're gnarly and a bunch of circular saw blades and stuff. And I was torching out knives, trying to grind them flat and shiny, and then trying to make a nice looking knife out of that whole thing that I could take to a craft fair and proudly display. It was a lot of hard work, and the marketing was really difficult. Craft fairs are not easy for me. Some people love them. I don't. So as you already noted, when one of the instructors and one of the students from the very first year of the Ron program, they had heard about me, that there was this knife maker guy in town. And they said, can you make these blades? And I basically said, no, go away. I'm busy. You're busy going broke, basically. And they insisted. Another friend of mine said, Ron, there's like 22 students. They do make 6 or 8 planes. You know, do the math, dummy. There's something there. So I showed up with a bunch of blades, and I stood there at that. There was a big round table in the foyer at the school. And I stood there, and I felt like a craps dealer or croupier, whatever you call that guy. And I was tossing out blades and raking in cash. And I came home with a bunch of money in my pocket. I said, Linda, there's a future here in this. Yeah. So that's the origin story right there.
Wow.
And a year or two later, I quit making knives. That way, it was not difficult to switch, because the woodworking market was much easier to tap into. Woodworkers are very enthusiastic about a better product, and Jim Kranoff himself he loved the fact that, you know, he'd go on these, he called it the song and dance. He'd go out into the world and do seminars and talk lectures and stuff. And so here he'd call me up, he'd say, Ron, I'm going to Denver to do the song and dance. And so I'd give him some brochures and a few plane blades, and he'd go talk about them and distribute this for me. He was like my rep, and he did never endorse products. This was because I closed a circle for him. If you read the books, he waxes poetic about how wonderful a hand plane is to use. And I agree, it's a delightful experience. So we're going to make a hand plane, right? This is the Kranoff philosophy. Well, we're going to go down to the hardware store and buy a $6 piece of junk Stanley block plane replacement blade, or a longer one. They have to hacksaw it off. And I mean, it was really a chore to make a wooden plane then. The chip breaker was a whole other, they called it breaker madness. They'd walk around the hardware store looking for something that they might be able to fashion into a breaker somehow. So I offered an easy solution to this, and they loved it. It was better than what they were doing and much easier. So one thing led to another. It's, you know, that's it.
It's fascinating, because you mentioned the chip breaker, but the Kranoff philosophy is the wooden plane that they make, right?
Yes.
And the chip breaker, are they using a chip breaker, or are they using the wooden wedge? No, that's just the cap.
There's a chip breaker. There's a wooden wedge on top of the chip breaker. Right.
Got it. Well, since we're talking about chip breakers, why don't we talk a little bit about why is a chip breaker important?
I spent years telling people that chip breakers really didn't do anything, because I couldn't figure out why they bothered with them. And then there was a study. I'm going to assume that most of you know about this Kato and Kawai, a Japanese.
I've seen the video.
It's fascinating.
It really is.
Try to track it down. Kato and Kawai is like, I don't know how it's Kawai or something like that. They showed that a breaker really does that, but that it breaks chips. The idea being that as a plane blade enters the wood, depending on which direction it's going, and you guys all know this, you know it empirically, or you just sort of intuitively, that the tear out is caused when the blade enters and lifts fibers ahead of it. Right. So several things help to prevent tear out. we're not talking about sharpening now. We're going to talk about plane geometry a little bit. A sharp blade, of course, is essential in this conversation. I still believe that a tight mouth is also another one of the bullets in our arsenal here to prevent tear out. I like to make the joke that I like the mouth setting to be just big enough to let the blue light through. In other words, just big enough to pass the shaving through and no bigger, because the leading edge of the mouth is holding the shaving down, as the fibers down as they're being sheared, so that there's no chance for levering up and lifting and tearing out.
Got it.
So, okay, so we got a sharp blade and a tight mouth. Now we set the breaker down really, really close. We're talking 3 or 4 thousandths off of the cutting edge of the blade. Really close. Yeah, it's almost, you almost can't see it. You have to look carefully to see the blade.
Okay. I'm too far back.
And there are people who will tell you that with that setting, even with a wider mouth, with that breaker setting, that tight, they can plane anything in any direction. So I challenge you all to run out to the shops and try it out.
Regardless of the angle of the blade?
Let's see. Think about that for a second.
Angle?
Oh, yeah, within certain limits. I'll say yes within certain limits. If again, a low angle plane aggravates the risk of tear out because it's getting under those fibers and lifting up. The higher angle planes will minimize the risk of tear out. That's one more weapon in the arsenal.
Yeah.
But most planes are fixed for their angle of attack, unless you put a back bevel on the blade, and people don't like to do that. So you'll see planes with steeper, where someone mentioned it or just earlier as we were chatting, you can buy frogs at probably 50 and 55 degrees. Yeah. The idea being that you're not sticking the blade down under and wedging it up to the fibers up. You're attacking them and smashing them basically as you go. A scraper is just the same thing, only it's all the way past vertical. A scraper without a hook will crush the fibers. There's no chance of tear out. It'll flatten anything, a true scraper. But you don't get the same satiny surface that you get with a plane. With the shearing action is beautiful and touchable. And whereas a scraped surface will be flat, but it'll have a matte, kind of a dull sheen. So you're going to have to fix that with finish.
So when did you get involved in the making chip breakers?
Oh, it just came along. It started with, and in fact, I hired my father's company down in LA to make the first ones because they did sheet metal, and then I had Larry out in the shop would grind the sort of roundy off the nose of the ones for the Krenov style blades. I avoided the whole thing for the longest time because, one, I didn't really believe chip breakers worked. And two, because most people were buying a replacement blade and they had a chip breaker that was adequate. But I got enough requests and we started making them as custom things, one-offs. And I said, okay, let's just go ahead and go for it. And I'm, to this day, surprised at how many breakers we sell. We sell a lot of chip breakers.
Well, I have to say, I picked up an old Stanley jack plane. And,
nice.
I switched it out with your chip breaker and your blade, and it made all the difference in the world. Well,
the sales pitch for our breaker is that in a bevel down plane, like a Stanley style bench plane, where the blade is used with the bevel down, the bevel of the blade is unsupported for its entire length. It's just out there bouncing around, right? So it will vibrate. Mm-hmm. And that's why you can hear what's going, planes make different noises with different settings, and it's the blade vibrating as it's going through the wood that you're listening to. So the chip breakers, and especially when it's set down very, very close to the edge, will preload that diving board and minimize the vibration. So a slightly heavier chip breaker, which ours is, will do that even more. So it damps vibration just by preloading. And I've had a number of people tell me they can hear the difference when they change out the chip breaker. I don't want to make this a big sales pitch, but that's the chip breaker story.
No, it's fascinating. Well, let's talk, since we're talking about it, O1, A1.
Yeah, the O stands for air. That means we can quench it in oil to harden it. That's the hardening step. Yeah. The A2, the A series are air hardening, which means they can be removed from the high temperature oven and they will fully harden fully quench in still air. The air will remove the heat fast enough to make the phase change.
But 01 is your favorite.
01's still my favorite. 01 is perfect in this application because it's a very simple steel. It's less than 1%, 0.95% carbon.
Right.
And basic, fully hardenable tool steel is iron and about 0.8% carbon. So 01 has just a smidge more carbon than it really needs to fully harden. The extra carbon turns into little iron carbides, which are nice little hard particles that help wear resistance and all of that. And the difference between Grandpa's chisel or plane blade, which would be probably a water hardening steel, which would be just a simple iron and carbon alloy, is that 01 has I forget, it's 1.5% or something of manganese. And the manganese is there, I believe it actually just physically, mechanically gets in the way of the carbon atoms as they're moving around during heat treatment. So it slows the quench rate requirement so that it can be quenched in oil, which removes heat more slowly. So the thermal shock is reduced. It reduces distortion and fracturing, and water hardening steels are difficult to work with. They can shatter. Trust me, I tried one once. It was horrible. And so air hardening steels then, which is almost all the other ones, all the high-speed steels, they all do air hardening. And a large part of the reason for their existence is simply to be able to air harden, because so much of this is used for metalworking. Woodworking, tool metallurgy has not advanced much at all in the last 100 years. Sorry guys, you're just not important enough for hand tools, for the metallurgical steel makers to care much, so they don't. So most of their effort goes into making tooling for metalworking industry, punching and stamping and machining and turning and all the stuff they do that have to run really hot. They got to run for a long time because they're doing, high production, lots and lots of parts. So that's where we want longevity and heat resistance, and the ultimate sharp edge is less important, and the angle of the edge is adjusted for the alloy so that they can hold up under the kind of punishment that a high-speed drill bit will go through when you're drilling through a piece of metal. Did that all make sense?
Yeah, totally. And it reminds me of a point you made that really resonated in your book for me, and that was the sweet spot of three things: sharpenability, durability, and corrosion.
Right.
Did I get that right? Are those the three?
You did. And for a woodworking hand tool, we don't care that much about the corrosion resistance part. That's the least important of those two. So we want edge retention, and we want it to be resharpenable. And 01 and A2 both fit that really quite well. They're both really good steels. They're easy to work with. The difference being that A2 has about 5% chromium. The 01 has either 0 or a very small amount. That amount of chromium forms, the chromium addition in the alloy form chromium carbides during heat treatment. Chromium carbides are large, hard, wear-resistant lumps in the steel, and they are what allow A2 to hold an edge longer. The downside, and I mentioned there's no free lunch. I think I say that several times in the book. Every trade-off. That is that those big lumps at very shallow, like paring chisel angles, bevel angles, 25 degrees or less, the lumps aren't held in, is it chemically?
Bond?
Whatever that is.
Yeah.
They're held in mechanically, like an old-fashioned amalgam filling in a tooth. They're just packed in there. They're just held in. So if we reduce the thickness of the metal down to a piece of paper, and then put pressure on it while sharpening or in use, that little piece of carbide is going to pop out. And people often complain about A2 edges crumbling or flaking or chipping prematurely. And it's usually because they have the bevel angle set down just a little too small. A2 performs best at 30, 32, 33 degrees for a chisel, 35 degrees. For a plane iron, you can't go steeper than about 32 degrees because of the clearance necessary in the plane on a 45-degree plane.
Does 01 get sharper
Thank you, Peter. Yes, it does, but it's on a metallurgical level and most people cannot tell the difference. My recommendation is if you're dimensioning, hogging a lot of wood, doing a lot of work, use the A2. It'll hold up longer and it'll get you down the road farther. But for finishing and polishing, even if you have to sharpen a bit more frequently, I still think, well, I hate to say it, but I think the old one has the edge. Sorry. I know.
Now, I just ordered a cryotonic blade from you. Talk
Good.
about that.
Sure. Let's see, how far back?
3,200, negative 3,200 degrees or something? It's
320.
Oh, okay. I had it as
hang on, I'm trying to figure out how far back I have to go to explain it. When the steel is quenched, during the hardening, it goes through a high temperature thing. It's all glowing orange and all that, and then we quench it in oil or air or whatever quenchant we're using. Oil or air, pretty much are the only two we're talking about here. What's happening internally is the crystal structure at high temperature has changed from ferrite to austenite. Don't take notes, it's really okay.
It's all in the book.
Yeah, it's all in the book. So when we quench it, we freeze the austenite into a yet third crystal structure called martensite. The steels that have the lower quench rate I have a trouble saying this, quench weight requirements, tend to fully quench the austenite into martensite, no problem. O1 does not respond, does not need the cryo treatment. But A2, because it is air quenching and all the other air quenchables, there's a real risk of what's called retained austenite. And you'll have austenite, which is a high temperature crystal structure, but it will stay in the steel at room temperature. You're getting no benefit from it. You paid extra for the carbon and all the stuff that's in there, and the austenite's not helping you out one bit. So we then can take it down to 320 below with liquid nitrogen or whatever's handy. And it will finally finish quenching the austenite into martensite. It has to be tempered one more time, but that's another story. But because we now have untempered martensite. Pardon me?
The benefit of this, the additional functionality or benefit?
We can now realize the full potential of the steel because all the austenite's now martensite, and we want the martensite. That's the hard, wear-resistant crystal structure that we want. So steels like that, the high-speed steels, cryogenic treatment is I started hearing about 45 years ago. And back then they didn't really understand metallurgically what was happening. They just knew it was working. And for a machine company that's, cranking out, a CNC machine company that was cranking out lots of parts, if they can go twice as long or 3 times as long or 10 times longer with cryogenically treated tooling, that's a huge cost savings for them, and it's way beneficial. And those are the steels that tend to have the retained austenite. So the cryo treatment helps them a lot. Cryo treatment, by the way, is, for reasons I don't understand, makes golf balls go farther, makes pantyhose more run resistant, and makes brass musical instruments sound better. And I don't think you'll find anyone in competitive target shooting or motorcycle racing or auto racing that doesn't cryo treat their camshafts, cranks, barrels. All the necessary wear parts are stabilized. Whatever it is, it's like a, what's that, accelerated aging process or something. But it does seem to work. There's science around it now and testing lots of good stuff. It's an amazing, it's kind of magic.
In your space, is this somewhat cutting edge? Is this a newer product for you, or
the cryo blades?
Yeah.
No. When we introduced the A2, it took me a while to come around to A2, only because I liked O1 so much. I thought, well, how much better can it be? Come on. Right. Well, there were enough other people using A2. It was starting to become popular, and honestly, I in my research, I was searching for this and that. I found a place that was using A2 for microtome blades. Those are the little planes that make those really thin slices of frozen tissue samples for pathology labs. It's a very demanding cutting application. And I thought, well, if it's working for them, it's probably pretty good.
Yeah.
So I did, I fiddled around some more, and I figured, well, if we're going to do A2 at all, we're going to go with the cryo. And so they came, whenever I first introduced the A2 blades, they've always been cryogenically treated.
Okay.
Yeah. But I did do an experiment. I did it up at the Krenov school years ago, where I gathered up I asked for volunteers, give me your blades, a bunch of blades, we have all kinds of weird stuff in there, mostly our 01 blades. And to make up the 30-pound minimum or whatever it was to have them cryo treated. And so I got them all back, oh goody, distributed them back to everybody, and never heard another word about it. Not one person ever said, gee, that was great, let's do it again. Never, not one. So I said, okay, 01 does not need cryogenic treatment. A2 does.
That's how you figured it out.
That's it.
Let's see, Bob, do we have any questions?
We do have a couple. One of them is, how can you tell the difference between A2 and O1 steel?
That's not easy. The blacksmiths would spark it. You can actually read the sparks of steel on a full-on bench grinder with a hard stone on it. As you all know, you make sparks, right? Well, the sparks are the metal burning in the air, and the way the different alloying elements burn will affect the little feathery flares and stuff on the spark itself. So O1 makes sort of long yellow or orangey yellow sparks with just a few little tails on them, whereas A2 will make a much featherier, brighter yellow spark because they're higher temperature and there's more elements in their burning. If you take a couple of pieces of things that what the alloys are, a drill bit or one of our blades, or our blades say either high carbon or A2 right on them, so you can tell. And just go test a corner, that not the bevel, just test it somewhere and just read some sparks and then start comparing things. You can actually get pretty close. That's how you can tell. Without sending it out for an analysis at a metallurgical lab, that's really all we got.
And you're reading the color of the sparks?
The color, yeah. You can search for them. There are places online. If you go search for grinding sparks or alloy sparks or something like that, you'll see a whole bunch of photographs, or some are just little drawings that people have drawn to say, yeah, it'll look like this.
Why don't we jump into how you define sharp? And I know in the book you talk about a zero radius.
Yeah.
You could expound on that a bit.
Okay, so a sharp edge is the intersection of two surfaces. We can call them planes, but then it gets confused with other kinds of planes. So the two surfaces meet they intersect at zero radius. Zero radius is a theoretical thing. There's really no such thing because everything has a certain size to it. The molecules have a size to it. There's always a radius, but we approach that. So the how to sharpen something is simply a matter, this will sound really simple, of abrading those two surfaces, be it the two parts of a kitchen knife edge or the bevel and the back of a plane blade, until those two surfaces meet at zero radius. That's all there is to sharpening. Once you get past that, however, it's a big field and there's lots of stuff. You could write a book on it.
And you did.
I did. Yeah. So the trick then is, and the choices for, you have to deal with the geometry. What bevel do you want? What you're using it for? All of those come into play. Not everything's going to get the same edge geometry because that just wouldn't work. Your kitchen knife needs something very different from your plane blade or your scraper blade or your saw blade. Yeah. So there's the geometry, and that then gets into the whole thing about honing guides and all of that, and holding a bevel and doing all that kind of stuff.
Yeah.
And then it comes down to what are we abrading it with? And people are often asking me, what should I use? And I say, well, what have you got? Yeah, I don't care if you drag it behind the truck on the way to town. If that achieves the goal, then we're there.
Yeah.
So there are three basic sharpening minerals, grits, if you will, grains, if you will. We use silicon dioxide, which is essentially a sand, which is the natural stones, the Washita stones and the Arkansas stones. Those are a silicon dioxide. Silicon dioxide particles are not very sharp, and they're not super hard. So some of those chromium carbides that I mentioned from the A2 are almost as hard as the abrasive that you're trying to abrade them with. So your natural Washita oil stones, they're going to be real slow with something like A2. The advantage to the oil stone, the natural stones, is that they're very hard, so they hold their shape really well. So if you're doing carving tools and gouges where you're rocking this edge and it's almost a point contact on a water stone, it'll cut a groove, but on a hard Arkansas stone, it'll maintain a shape. So then that's silicon dioxide. Aluminum oxide is probably the workhorse in this industry. That's what most water stones are made from, and they are somehow, it's a finely graded grit of aluminum oxide held together with some binder that they don't ever talk about because that's all proprietary. And they're made to wear down quickly to expose new grit all the time as you're working. And therefore they need to be reflattened frequently. And if you did try to sharpen your carving gouge on it, you would probably put a big old groove right down the middle of your favorite water stone. Yes. Diamonds, the ubiquity of diamonds as abrasives has, I think, changed everything. And everyone's kind of getting caught up on this. It's been a number of years, but I have a friend that is convinced that the reason carbide machine tools are becoming so inexpensive is because the diamonds required to machine them to make the carbide shapes has become so inexpensive that they can now machine them into shape more inexpensively. So for us, that means, the DMT flat plates, you got a metal plate, you got diamonds on it. You'll still wear a groove, even though it won't be visible, but it'll dull a spot if you try to put too much pressure with that same carving gouge. But for plain blades and flat chisels and all that kind of stuff, they work pretty well, and they don't require pretty much any maintenance compared to water stones. So we have those three minerals are doing most of the heavy lifting here. People ask, what should I use? They buy a blade at a show. Okay, well, how should I sharpen that? Well, what do you got? I got a thing from my grandpa, and I got another thing. I say, fine, learn to use them. This is from a tool maker. I say technique is more important than tools. Learn how to sharpen, and what you need to use to sharpen will become much more obvious as you get better at it. Your kit will start to enlarge. You'll start getting all kinds of doodads. If you've ever seen a carver's sharpening station, it's an incredible, it kind of looks like someone dumped the Legos out on that or something, because they've got all kinds of doodads and little dowels with sandpaper glued on them, because they have to get very creative to get inside of all those things. And they have a whole variety of special little bespoke sharpening tools.
Well, that's one thing I loved about your book too, is all the photos you had. I think you had over 400 photos.
I took a lot of pictures, yeah.
Yeah, and also you really surveyed the field of sharpening tools, approaches, techniques, products. I learned a bunch of new approaches to sharpening I wasn't even aware of.
I wanted to be encyclopedic. People often ask, well, what should I do? And what do you recommend? And I don't recommend.
Right.
Because everything we've mentioned, everything you can think of that is used in sharpening, either the abrasives or the gizmos or the power tools, they all have adherents and they all have detractors. Someone hates them, someone loves them. Yep. So obviously they all work because the goal is zero radius with a polished edge. The goal, actually, that isn't even really the goal. The goal is a perfect surface that you want. The goal is the result of the action of the tool.
I want good results.
Getting that by using I don't care what, then you're succeeding.
Yeah.
Yay. Congratulations.
Yeah, absolutely.
So it just comes down, and I recommend that, and I know this isn't the time we've got a pandemic going on, so it's not the time to go to the club meeting and bring all your sharpening gear, or go to the sharpening lecture at the local woodcraft store. But when you can do that, get your hands on as many different things as you can. Unless you're if you're happy with your kit, don't mess with it. Congratulations. But if not, then go someplace where you can actually try out a few different stones.
Right.
Try the expensive stones, try the cheap stones, try the sandpaper, the honing film.
Yeah.
It all works.
You know, what I've been struggling with is flattening the back of
Yeah.
my blade. That's the most time consuming. And the one tip that I got from one of many from your book was changing the angle so you can see more easily.
Oh, yes.
That's
Not
such a great,
the angle of that you're actually abrading.
right.
Rather than the angle of the bevel angle.
No, but switching the angle on the stone so you can see when the previous pass abrasions are gone when you change grit. Yeah. Every grit changed the angle of approach.
It's a little non-ergonomic because some of those are awkward.
Yeah.
But it's worth it for exactly that reason. You can tell how you're doing.
Yeah, I want to make sure that was clear. So what Ron was recommending, which is really, I think, super helpful for me, is flattening the back. Each grit you go through, change, let's say you're starting this way with the coarsest grit, and then you switch to the next grit, switch this way, go this way. And the reason is you can tell when the previous grit scratches are gone, and then you alternate. Did I explain that correctly?
Yeah, yes.
So we have a few questions in the chat here. One of them is, are the diamond stones man-made diamonds or natural diamonds?
They're all man-made. I say that as if I know for a fact. I don't know for a fact, but I'm confident that it's because we are getting so good at making diamonds that diamonds have become, diamond nail files. Come on.
There's some questions about strop, to strop or not to strop.
Yeah, I think I answered that here. Yes, no.
Really?
Well, some people don't like them because there's a risk of rolling off because a strop has some compressibility to it. There's a risk that as you push hard and roll and to remove that final burr and polish the edge to the, I forget what the chrome oxide is, but it's like a 30,000 grit abrasive or something really small. So you can polish that and remove that last burr with it. And I use it. When I sharpen stuff, I like that final strop. It makes me feel like I did the last thing. I'm confident that there's no burr left, and I'm gentle about not compressing the leather if you're using leather. You can people strop on MDF, anything that'll hold that crayon green abrasive that you're rubbing on there. If you're confident in your sharpening and you're chasing the burr, you're flipping back and forth, and you're going maybe past 8,000 grit, you may be taking the burr off adequately. And again, it's empirical. If you're getting the surface that you like and the edge retention that you like, then and don't add stropping to your kit if you're really happy with the results you're getting. I think it finishes things, and I'm confident that it does. But if you're confident that your 8,000 grit stone is not leaving a burr, and you can take a piece of paper and just cut it by just holding it like that, you're there. Congratulations.
Well, that's interesting. The paper approach. There's the fingernail approach, the paper approach. Do you have a preference? I guess paper is what you.
Well, I think the paper is actually one of the most demanding, and you can hear exactly what's going on. If I'm just sharpening a knife in the kitchen, I just touch it on my thumbnail. It looks creepy to people who've never seen it done, where you just do that.
Yeah.
You can use a plastic pen or something. It'll telegraph. And if you slide it along like you were trying to cut it, but really gently, you'll feel any imperfection. It telegraphs like crazy. A thumbnail will do the same thing. Again, it looks creepy because you're doing this with your thumbnail. But if there's an imperfection on that edge, you'll feel it, and it can be incredibly small, and you'll know about it.
So you're saying if it's a knife blade, you take it across the fingernail this way to feel the imperfections?
I do a knife. I don't have anything I can show this with, but if this was a knife, I would just touch it. If it hangs up, it's sharp. If it skids at all, it's not sharp.
Right.
But then if I want to check the whole edge, I will slide it oh so gently. Again, it looks creepy, but it isn't, and we're not putting any pressure on the thing. But you'll feel any little imperfection, and it's very, very sensitive.
Okay.
We had one question a little while back about putting a what is the importance of a back bevel? I assume that's on a chisel or a hand plane. What do you think about back bevels?
Back on a plane, first of all, on a chisel, I think it's not recommended because you want the back to be perfectly dead flat. Because there are times when you want that chisel to slide right along the surface and cut something right in the corner. And if there's any bevel back there at all, it'll just climb up on it instead of cutting the fibers.
Yeah, I agree.
For a plane blade, however, and people are very reluctant to do this, but it's a well-known, a well-respected way to achieve a steeper angle of attack for tear-out reasons. If you're doing some very difficult woods, you can put a back bevel on the blade so that how do I describe without a back bevel and a 45-degree frog, the angle of attack is 45 degrees. So if you put a 5-degree bevel on there, you're now attacking at 50 degrees. And the chip breaker will fit over, as 5 degrees is not very much. So the reason I think people are reluctant to do that is simply because if they don't want it anymore, they got to grind that whole thing off. And that seems horribly, horribly wasteful. But in my opinion, it's not that different from having a bevel up plane, the bevel up smoothers that are so popular. And so a lot of people have 2 or 3 blades for those so that they have the different angles of attack. And that's a real advantage to a bevel up plane, is you can change the angle of attack by just changing your bevel angle slightly. So there's a whole book. Brian Burns is a friend of mine who happens to live not far from here. He did a little self-published book called Double Bevel Sharpening. And he talks about how he even advocates it for joiner knives, putting a slight back bevel on them. It requires more power because a steeper angle of attack, you have to push harder to crush the fibers and shear them. But he says you'll get less tear out from your planer or joiner if you put a back bevel on your knives. Did that answer the question?
Yes, definitely.
Okay.
We have another question. What type of lubricant are you using on the stone?
Well, water stones, we use water. A drop of soap helps with just keeping things, the swarf, the black stuff that comes off the blade, keeps it in solution. Oil stones you can use either with soapy water or oil, but if you've used them with oil, you've got to stick with oil. For honing film, I will actually grab, if I've got a thing of soapy water nearby, I'll squirt it with that. I've used WD-40 on it before also, just because it was handy and I was in a hurry.
With water stones, I've always been curious if I can just leave them in the water, in my little bath when I'm not using them. Is there any detriment to leaving them in the water all the time?
No. In fact, I think it's beneficial, but not with the Sharpen style. What do they call those? Ceramic water stones or something?
Okay.
Those apparently you're not supposed to leave wet, and don't soak them. You just spritz them. They want water on the surface, but they don't want to be soaked, so they don't absorb water, and you don't want to expect them to. I think it actually damages the stone. And if you keep your stones, I know we're in California, so this is not a big deal, but if you store your stones in water, I mean, I have a Rubbermaid tub that's got stones in it. That's where they live. And if your shop's not heated, don't let them freeze because it'll break your stones.
Mm-hmm. Mm-hmm. How about rust? The famous song by Neil Young, "Rust Never Sleeps." And indeed, he's right. I was just saying, you may have heard me during our soft start. I said, I've been working with green wood, and I'm starting to experience some beginnings of rust on my tools, and even on my bandsaw table.
I'm 2 miles from the Pacific Ocean. Rust has been a thing.
Yeah.
We used to buy WD-40 literally by the gallon and use it a lot. We get one of those green ammo cans and just fill it with WD, and everything went in and soaked and then got drained. And we still do, but we use something that's just a little fancier than that. But basically, it's still the same kind of stuff. So,
and when you have rust, what's your favorite? Do you go with your electrolysis, or do you go with a citric solution of some? I
like the electrolysis because the electrolytic rust removal does not remove any steel. The base metal is never touched.
Whereas,
assuming you don't screw up your polarity, the rusty thing is on the negative. The whatever you call the other part is the anode. It's on the positive. If you reverse those, you'll be really sorry because it will just dissolve the other one. It's horrible.
The steel. It will eat into the steel.
Yeah. But the electrolysis eats only the rust. Only the iron oxide comes out. So you can leave it in there indefinitely. There's absolutely no worry about it. It'll continue to bubble and you keep thinking it's doing something, but all it's doing is splitting the hydrogen and oxygen.
Right.
But it won't take anything more than just the rust off.
Now,
so that's in contrast to an acidic solution like vinegar that might wear down the steel over time?
It would over time. A lot of people use those kinds of things, and there's evaporust, which honestly I don't know that much about. If you use an acidic approach, be careful, keep an eye on things, and just, when it's right, be done, rinse it off real well. Maybe soak it in a little baking soda solution just to be sure to neutralize things. Any acid anywhere near your tools is really insidious. Linda was, my wife Linda was, what's it called? Zesting lemons. She was peeling with a knife, peeling lemons, sitting down here. We were watching TV and she was doing this. I finally looked at her and then she was scraping all the white stuff off the inside and spending a lot of time. I said, well, that's a spoke shave job. So I went and got the 151 and set it just right. And she just basically just peeled, it worked beautifully. And I rinsed it really well when it was done and it still rusted like crazy.
Wow.
So sorry that I had that idea.
Well, that's good to know.
Oh man, it was horrible.
A few other tips I'll just mention that, were fun for me and I'll pass on is sharpening your scissors with your burnisher. I loved that, man.
A lot of people,
It works. I tried it.
Yes, I know. It works like crazy.
You take your burnisher and you start cutting it with your scissors.
Yep, as if you were trying to cut the burnisher. Just run it back and forth. It won't fix a bad pair. If you've been using your scissors for cutting sandpaper, forget about it.
Right.
But if they're just getting a little dull or the fabric, your wife's scissors are maybe you're starting to hang up a little bit or something.
Yeah, it's great.
It's great, and it's so easy. It's so incredibly simple.
Another one, and I know we're out of time, but another one is folding the paper 3 times to get to the angle. Fold it 45, then 22, and then 11 1/4.
Just little tricks we learn along the way
to find the right angle for sharpening.
The scissor thing I learned from my mother told me about. Her mother had used the neck of a milk bottle.
That's right. Yeah. Another plug for the book is all the microscopic photography you have in the appendix toward the end of the book.
That was a very humbling day.
Oh my! It was Sonoma State, I think you went to.
Yes. Yeah.
And you took your sharpest blades with you. You were pretty surprised by the resulting photographs.
They looked awful. I couldn't believe what a lousy sharpener I am.
But it's all about the result, right?
That's
You're
right.
Getting good results from those blades.
I'm an empiricist. That's
so
right.
What is sharp? Yeah, empirical results.
Yeah.
Ron, we could go on and on and on. And
I hope this helped. If anyone has questions, I try to be available. I'm ron@hocktools.com. If you have questions about stuff, don't hesitate to ask. I'll do my best.
Thank you, Ron, for
taking
Morgan.
the time. Bob, thank you. Everybody, thanks. Nice to see you.
Welcome.
Really terrific. Have a great rest of your week and weekend, and we'll be in touch, Ron.
Thank you.
Thank you.
Take care,
so
everybody.
much, Ron.
Bye.
All righty. Thank you. Bye-bye.
Bye.